Hello, students. Mr. Madison here with another instructional video that has been designed with you in mind. The objective here, which I'll write out for you so that everybody's clear on exactly what it is we're trying to do. Our goal for today is to be able to find something that's called the arc length. So I will define for you what is meant by arc length. I'll give you a formula for arc length, and I will demonstrate for you several different types of problems involving arc length. So once again, our objective is that by the end of this instructional video, everyone will be able to solve problems involving arc length. Let me start by talking about something that you're probably familiar with. So I've got a circle here. And you folks know that when we talk about perimeter of a figure, we're talking about the distance around the figure, and we can always find the perimeter by adding up the sides. Well, the perimeter of a circle is called its circumference. So the distance all the way around that circle is called the circumference. Now you know that the distance across the circle through the center point is the circle's diameter. So the distance around is the circumference. So we're going to let C stand for the circumference. We are going to let D then represent the diameter. So here's the deal. Centuries ago, probably ancient Greece, it was discovered that if you measure the distance around a circle, and that would be the circumference, and you form a ratio between the distance around the circle and the distance across the circle, in other words, if you take the circumference and divide it by the diameter, it doesn't matter which circle or what size circle you're working with. This ratio will always be the exact same value. So what I'm telling you is if you have, say, a smaller circle, and you measure the distance around this small circle, and then you measure the distance across the circle, and you form a ratio between the distance around and the distance across, you're going to get the same value as you did up here with this bigger circle. In fact, if you have a small circle and you measure the distance around, and then you measure the distance across, and you form a ratio between the circumference and the diameter here. When you divide this out, this C divided by D will give you the exact same value as this C divided by D, and the exact same value as this C divided by D. And folks, that value we affectionately refer to as pi. And you guys usually have the number 3.14 pop into your brain as soon as you see that pi. And 3.14 is, of course, an approximation or a truncation for a non-ending, non-repeating value that we know as pi. So here's the deal. If you take this relationship right here and you multiply both sides of this equation by d, these d's cancel. And what you end up with then is a formula for the circumference. Circumference equals pi times the diameter. Now there's an alternate formula that we sometimes use. You know that this distance here is the radius. And we'll let r represent the radius. But if you take the radius and you double it, multiply it by 2, you'll get the diameter. So we know that 2 times the radius is equal to the diameter. So if I take this 2r right here, and I substitute it right here for the d, I'm going to get a secondary formula for circumference. I'm going to have circumference is equal to, and then instead of having d, I'm going to have 2 times r. But I'm going to put them in this order. I'm going to have the 2, I'll put the pi in the middle, and I'll put the r on the end. So this 2 times r is the same as that d. So here we have it. These are 2 different formula that you could use anytime you're asked to find the circumference of a circle. Now, I need to make sure that no one is confused about the difference between the degrees in a circle and the distance around the circle. When you look at these circles that I've drawn, the big one at the top, the medium-sized one here, the small one here, each of these 3 circles has 360 degrees in it. Every circle, or all circles, contain 360 degrees. But when we're talking about circumference, we're not talking about degrees. We're talking about distance. Your units for circumference are going to be units of distance or units of length. We're talking inches or feet. Could even be miles, but it has to be some sort of a unit that conveys distance. This circle here has 360 degrees, but obviously the distance around this circle is greater than the distance around this circle, which is greater than the distance around this circle. So there's a difference then between talking about the number of degrees and talking about the number of inches or number of feet. So keep that in mind. When we're talking about circumference, we're talking about units of length. Units of length or distance when we're talking about circumference. All right. Something I'd like to show you here, this is just sort of a little table, just a little problem-solving technique that you might use at different times. And the point here is that you have these 3 variables, radius, diameter, and circumference. And the point is that if you know one of those, any one of those, you can get the other 2. So for example, if I tell you that the radius is 3 inches, then the diameter has to be 2 times the radius. So it'd be 6 inches. And then the circumference has to be whatever the diameter is multiplied by pi. So I'm going to write just 6 pi inches here. Let me pause for a moment and explain something to you. This value right here, 6 pi, which represents the circumference, is a value that's given to you in what we call in terms of pi. In other words, there's a pi in the answer. There's a pi as part of that value that's given, 6 pi. Anytime you're asked to find circumference, you could be asked to find circumference in terms of pi, because that's how you get circumference. You multiply the diameter times pi. So the circumference here you could just simply say is 6 pi. Some situations, you may actually want to take the 6 and multiply it by pi, and you would use your calculator to do that. You'd take 6 times 3.14 and express your answer as a decimal. But this expression right here, 6 pi, is what we call in terms of pi. And a lot of the problems that you'll be doing involving arc length, involving circumference, are going to ask you to find your answer in terms of pi. Let's suppose that the radius is 11 inches. Then I know that the diameter would be double, which would be 22 inches, which makes the circumference 22 pi inches. Now let's suppose that the diameter is 40 inches. Well, the circumference would be 40 pi then, inches. And to get the radius, I'd take my 40 and divide it by 2, so it'd be 20. Let's suppose that the circumference is 8 pi. Well, that would mean that the diameter would be 8, and the radius would be half of that, 4. Let's do one more. Let's suppose that the circumference is pi inches. Well, don't forget, there's really a 1 right there. So that makes the diameter 1 inch, and it would make the radius 1/2 of an inch. So this table right here is just a way to organize your information, and you might want to use this when you're solving problems to help yourself find these different values. But the point is that if you know one of them, doesn't matter which one, you can get the other two. All right, onward we go. We're going to talk about arc length. And I'm going to create a problem here and ask you a question in order to introduce the concept of arc length. So here's a circle, and this is the center right here. And I'm going to draw in a couple radii and make a central angle here. And in fact, I'm going to draw this central angle so that it is a right angle right here. This is a right angle right here. Now, I'm going to tell you that the radius of this circle is 12 inches. And this point right here, I'm going to call point A. And this point right here, I'm going to call point B. Now, here's what I'm going to do next. I'm going to put a little bug on this circle. So I'm going to put a little bug right here. Here's my little bug. Got a couple antennae, and most insects have 6 legs. So this is my bug. And here's my question. If this bug crawls along the circle from point A to point B, so this would be its path right here to point B, how far would the bug crawl? How far? So that's the question. How far will the bug crawl from A to B? Now, here's the first point that I need to emphasize to you. My answer to this question will not be a certain number of degrees. You see, it asks how far, not asking you how many degrees. We know that the central angle, which in this case has a measure of 90, and the intercepted arc, and this would be the intercepted arc here, I'll scribble on it, have the same degree measure. So this would be a 90-degree arc. But that's not the question. The question is, how far? This question is an arc length question. Arc length is distance, not degrees. And what you need to understand is that the bug, when it crawls from A to B, it is not crawling all the way around the circle. Because if it crawled all the way around the circle, we would pretty much know what the answer is. The answer would be whatever the circumference of the circle is, because all the way around would be the circumference. But instead, the bug crawls a certain part of the way around the circle. So arc length, then, is equal to some fraction or some part times the circumference. That's the concept. Arc length is some fractional part of the circumference. So we already know what the circumference is. The circumference is given by the formula 2 times pi times r, right here. We have that. This fraction right here, we have to figure out what that fraction is. To figure out what that fraction is, we need to go back and look at the degree measure of this central angle. You see, this is a 90-degree angle, which results in a 90-degree arc. But we know that all the way around the circle is 360 degrees. So when our bug crawls from A to B, it crawls through 90 degrees of the 360 degrees in the circle. So to figure out this fraction right here, what we're going to do is we're going to take the degree measure of this central angle right here. For right now, we'll just call it x. And we'll divide that by 360. And let me put a note here. This x right here is the degree measure of the central angle. Now, when I take this right here, and kind of clean it up a little bit, here's what I'm going to have. I'm going to have arc length, and I usually use A period, L period for arc length, is equal to x over 360 times 2 times pi times r. This, students, is our arc length formula. This will be our primary tool going forward here. Any arc length problem that you're going to do, you could pretty much start by writing down that formula and then plugging into the formula whatever values you're given in the problem. So this is what we're going to use. Arc length is x over 360 times 2 times pi times r. The radius is this distance on the circle. The 360 is how many degrees all the way around. The x is the degree measure of that central angle. For this problem right here, we're going to answer the question, how far will the bug crawl from A to B? So the distance the bug will crawl is the arc length. And that's going to equal 90 divided by 360 times 2 times pi times the radius, which is 12 inches. Now, I'm going to say to you, give me the answer in terms of pi, which means this pi is just kind of going along for the ride. I can go ahead and write the pi down here. Then I have to do my arithmetic. I have to multiply 90 over 360 times 2 times 12. Now I know that 90 over 360 is 1/4. And 1/4 of 12 is 3, times 2 would be 6. So it's going to be 6 pi inches. If I needed an answer, if I had to have an answer that was not in terms of pi, I'm just going to go 6 times pi on my calculator, and I'm going to find out that's approximately equal to 18.85 inches. So that's our very first arc length problem right there. How far did the bug crawl? Let's do some more. I'll make a circle. And let's see, on this circle, I'm going to put some central angles. This is the center of the circle. And let's say that this angle right here is 90. And let's say this angle right here, oh, it looks like about 30 degrees. And let's put an angle over here. That angle looks about, I'll tell you what, let's go ahead and make this. Let's go ahead and make this, just because of the way I drew it, it looks like it's cutting the circle in half. Let's go ahead and make this right here a diameter, okay? So if that's a diameter, we know from this point around to this point would be 180. So this guy right here is going to have to be 60 degrees, all right? Now, I'm going to put some points on here. Let's call this A, B, C, and D. All right. And I'm going to tell you that the radius of this circle is equal to 60 inches. And I want to find the arc length of some different arcs here. So I'm going to find the arc length of AB. I'm going to find the arc length of BC. I'm going to find the arc length of CD. And for right now, let's just leave it at that. How am I going to find those arc lengths? Answer, I'm going to use this formula. Arc length equals x over 360 times 2 times pi times r. So this is my primary tool right here. This is my arc length formula. So here we go. The arc length of AB is going to equal the degree measure of that arc, which is 30 degrees, divided by 360 times 2 times pi times the radius of the circle, which is 60. I'm going to go ahead and write these other two out. We'll come back and do the arithmetic in a moment. So the arc length of BC, if I want to find the arc length of BC, I have to put the degree measure of that arc, which is 90 over 360. That 90 over 360 is the fractional part of the circumference that the arc is. It's 90/360ths of the circumference times 2 times pi times the radius of the circle, which is 60. And then for CD, I'm going to have 60 over 360 times 2 times pi times 60. All right, now, I'm going to get all of my answers in terms of pi. So I can go ahead and write a pi here. Now for this one, I'm going to have to multiply 30 over 360 times 2 times 60. And you can do that just like you see it on your calculator. I'm just going to kind of do a little arithmetic out loud here. Let's see, 30 out of 360 would be 1/12. And 60 divided by 12 is 5 times 2 would be 10 pi inches. Now 90 over 360 would be the same as 1/4. And 60 divided by 4 would be 15 times 2 would be 30 pi inches. Let me pause for a moment. Doesn't it make sense to you that this arc that's 30 degrees and this arc that's 90 degrees, that the arc length would be 3 times 10 pi would be 30 pi, and 3 times 30 would be 90. That makes sense. And then on this last one here, this is the same as 1/6 here, and 60 divided by 6 is 10 times 2 would be 20 pi inches. So there you have it, 3 quick examples of arc length problems. Let's suppose, though, that I wanted to find the arc length of AC. Well, instead of using my formula on this one, all I'm going to do is I'm going to add the arc length of AB to the arc length of BC. So AB is 10 pi and BC is 30 pi, so A to C would have to be 40 pi. That makes sense to everybody? Let's do some more examples. All right. Look at this. Here's a circle that has a central angle of 60 degrees. Here. And this is point N, and this is point J. I'm going to put another point right over here called point S. And I'm going to tell you that the radius of this circle is 9 inches. Be careful, though. Look at the question. We want to find the arc length of arc NSJ. In other words, how far is it from N, not from N to J this way, but from N through S to J, the long way around? When you set this problem up using your formula here, you have to be careful with the number you put right here on top. This is a 60-degree arc from N to J, which means it has to be a 300-degree arc from N around to J the long way. So what I'm trying to emphasize to you is this number on top is 300. That major arc would be 360 minus that minor arc of 60, times 2 times pi times the radius, which is 9. Now, 300 out of 360 is the same as 5/6. And 2 times 9 is 18. Divided by 6 is 3 times 5. It would be 15 pi inches. So in this problem, what I tried to do for you was to emphasize that you have to be careful, make sure you know which arc you're finding the length of. In this problem, we are not finding the length from N to J this way. We are finding the length from N all the way around to J, which necessitates us putting 300 degrees on top for that problem. Don't get stumped by a problem like that. Let's do some more examples. I'm going to draw in a diameter in this circle. So this would be the center right there. And let's say this angle, this central angle right here measures 36 degrees. And this central angle right here measures 45 degrees. I'm going to label some points. We'll call this W. We'll call this T. We'll call this H. And we'll call this K over here. And we're just going to find some different arc lengths. First of all, let's find the arc length of arc WT. And we're going to find the arc length of arc TH. We'll find the arc length of WH. We'll find the arc length of WK. And lastly, we'll find the arc length of HK. All right. How are we going to find all those arc lengths? We're going to use our arc length formula. Arc length equals x over 360 times 2 times pi times r. This is our primary tool. You need to know this formula right here. All right, here we go. WT. WT is a 36-degree arc. So I'm going to have 36 divided by 360 times 2 times pi times the radius. I can't do anything without the radius. I'm going to tell you guys right now that the radius of this circle is 20 inches times 20. And TH is an arc that has a degree measure of 45. So I'd have 45 out of 360 times 2 times pi times 20. All right, let's go ahead and get these two. 36 out of 360. And again, I'm doing this arithmetic, just doing a little mental math. You can just do it on your calculator. So if you don't follow exactly what I'm doing as I'm getting my final answer here, don't panic. I know that my answer is going to be in terms of pi. So I'll put a pi down. Same here. Then 36 over 360 is 1 out of 10. And 20 divided by 10 is 2 times that 2 gives me 4 pi inches. Now 45 out of 360 is the same as 1/8. So 2 times 20 is 40, divided by 8 would be 5 pi inches. Now WH goes from here to here. You know what? To get WH, here's what I'm going to do. I'm just going to add WT and TH. So I've got 4 pi and 5 pi. This is 4 pi here, and this is 5 pi here. Stands to reason that from W to H would have to be 9 pi. WK, well, you know what? I got a little issue. I got to figure out what number to put in my numerator here. Well, here's the deal. If that's 36, this angle, then this guy that's adjacent to it here along this straight line has to be 144. They have to be supplementary. Might as well do this one too. If this is 45, this got to be 135. Once again, that 36 and that 144 got to add to 180. That 45 and that 135 got to add to 180. So when I'm trying to find WK, I'm going to have 144 over 360 times 2 times pi times the radius, which is 20. And to get HK, I'll have 135 over 360 times 2 times pi times 20. All right, time for me to do my arithmetic. Let's see. This would be the same as 2/5. And then 20 divided by 5 is 4 times 4 would be 16 pi. And 135 over 360 is the same as 3/8. 2 times 20 is 40. Divided by 8 is 5 times 3 would be 15 pi inches. So there you have it. 5 more quick examples of how to find arc length. Let's do just a few more problems, and these next few problems are going to have a little twist to them, so make sure you're paying close attention. Okay. Here's a circle, and I'm going to put a central angle in this circle. The central angle here is a central angle with a degree measure of 80. All right. Now this would be the intercepted arc of that angle, and I'm going to tell you that the arc length of that arc is 8 pi inches. You see how this problem is different already? In all the other problems, we had to find that value. We had to find the arc length. But in the outset of this problem, I'm telling you what the arc length is. And I'm telling you the degree measure of the central angle. But here's what I'm not telling you. I'm not telling you what R is. So our job is to find R. How do we do it? Well, our primary tool is our arc length formula. So always start by writing down your arc length formula. Arc length equals X over 360 times 2 times pi times R. Now, I'd like you to examine this arc length formula for a moment. When you look at this equation, what you need to see is that there are 3 unknowns, or 3 variables. You have R, you have X, and you also have arc length. In any problem, you're going to be given 2 of those variables, 2 values, and then you're going to be asked to solve for the third one. It could be any 2, and you could be asked to solve for any one of those 3. In this problem, we know the arc length, and we know X, but we don't know R. So all I'm going to do is start my problem by substituting into my formula the 2 values that I am given. So I'm going to put in 8 pi for arc length. X is 80 times 2 times pi times R. Now at this point, what has to happen is your finely honed algebra skills need to kick in, and you need to isolate R. So there's different ways you can do it. I'm just going to kind of think out loud and explain what I'm doing. I see a pi on the right and a pi on the left. So if I would divide both sides by pi, I could eliminate the pi. So I'm just going to shortcut it and just draw a line through those. So the pi's are gone. So now I need to get the R by itself. So here's my 8 over here. I'm going to write that down. To isolate this R, I need to get rid of this 80 over 360. One way I can do that is to multiply by the reciprocal. So I'm going to multiply by 360 over 80. And I need to get rid of this 2. And one way I could do that is to multiply by 1/2. And that will give me R. So I'm going to just pick up my calculator just to expedite. And here's what I'm doing in my calculator. I'm going to take that 8 and I'm going to put it in. And then anything over here that's being multiplied by the R, I'm going to divide by. And anything over here that's being divided into the R, which would be the 360, I'm going to multiply by. So in my calculator, I'm going to go 8 times 360. And I usually do this in steps. So I hit enter. Then I'm going to go divided by 80, enter. Then I'm going to go divided by 2, enter. And is that the quickest way? No, but it works. And I find that the radius of this circle would be 18 inches. So very quickly, let's review what we did on this problem. We are given the degree measure of the central angle. We are given the arc length. We are asked to find the radius. So we took the 2 values we were given and we put them into the formula, and then we used algebra to isolate R. Let's do another problem. Okay, here's a central angle. And this central angle has a degree measure of 144 degrees. This would be the part of the circle here that I'm scribbling on is the intercepted arc of that central angle. And I'm telling you up front that it has an arc length of 24 pi inches. And my question to you is, what's r? So once again, I'm going to start by writing down my arc length formula. Arc length equals x over 360 times 2 times pi times r. Then I'm going to take whatever values I'm given and plug them into the formula. I already know the arc length, so I'm going to put 24 pi equals x is 144 divided by 360 times 2 times pi times r. I notice a pi on the right and a pi on the left, so the pi's cancel out. That's what happens if you would divide both sides of your equation by pi. Now I need to isolate the r. So I'm going to write down 24. I'm going to multiply by the reciprocal of 144 over 360. So I'm going to multiply by 360 over 144. And to get rid of the 2, I'm going to multiply by 1/2, which is the same as dividing by 2. I'm going to do this on my calculator, and I'll just verbalize what I'm doing. I'm going to do 24 times 360. I'm going to do enter, divided by 144, enter, divided by 2, enter, and it turns out that the radius of this circle would be 30 inches. Just a couple more problems for you, and we'll be done. So here's a circle, and I'm going to put a central angle in here. And I'm not going to tell you what the degree measure of that angle is. In fact, I'm going to put x degrees there. And that's what we're going to have to figure out. But I will tell you that the intercepted arc has a length that's equal to 4 pi inches. And I will tell you that the radius of this circle is 18 inches. And our job is to figure out what x is. So how do we do that? Start by writing your formula for arc length. Arc length equals x over 360 times 2 times pi times r. Plug into the formula the values you are given. So we have the arc length, so I'll put 4 pi in for that. X I don't know, so I just put the x in. Times 2 times pi. I do know the radius is 18. All right, the pi's cancel, and I have to isolate the x. So here's my 4 on the left, and I'm going to have to multiply by 360, multiply by 1/2, multiply by 1/18 in order to isolate the r. Now, when I'm multiplying by 1/2, you may think about it as dividing by 2. Same with this. When I multiply by 1/18, you might be thinking divide by 18. It's the same thing. So I'm going to go to my calculator, and this is what I'm putting into my calculator. 4 times 360, and I usually do this in steps, enter, divided by 2, enter, divided by 18, enter, and I'm coming up with a radius of 40 inches. I'm sorry, a degree measure of 40 degrees. And this would be x here. I apologize for that. That's x, and this is x. All right. I made a boo-boo right there. That's x. X is there. Let's do another problem. Last problem, folks. Here you have a circle with the central angle, and the measure of that central angle is x degrees. The intercepted arc of that central angle has a length of 24 pi inches. And the radius of this circle is 45 inches. And our job is to solve for x. I always start by writing my arc length formula. Arc length equals x over 360 times 2 times pi times r. Substitute into the formula the values you're given and solve for that third value, which in this case is x. Arc length is 24, so I'd have 24 pi for my arc length equals x over 360 times 2 times pi times the radius, which is given as 45. The pi's cancel. I need to isolate the x. So I'm going to have 24 times 360 times 1 over 2 times 1 over 45 is equal to x. Picking up the calculator, I'm going to have 24 times 360, enter, divided by 2, enter, divided by 45, enter, and I'm getting that that angle has to have a degree measure of 96, and I'm done. So in these two problems right here, we solved for x in each case. In these two problems, we solved for r. But in all of those problems, I start by writing down my formula and substituting in the values that I'm given. A quick review, and then we'll call it quits. We started by talking about the meaning of circumference. Circumference is to circles what perimeter is to any other type of figure. It's the distance around. And we came up with the formula for circumference, pi times the diameter, and then an alternate formula, pi times 2 pi r. I gave you this little table as a problem-solving tool, and the point was that if you know any of these three values, you can get the other two. We developed an arc length formula. The arc length is always a certain fraction times the circumference of the circle. The certain fraction is derived by taking the degree measure of the central angle and dividing by 360. And then our circumference is 2 pi r. This is our primary tool. And every problem that we did here, we started by writing down that formula. These problems here, I gave you the radius, and I gave you the degree measure of the angle. So we had a value for x, and we had a value for r, and we just plugged it in, and we did our calculation, and we came up with our arc length. When we found our arc length for all of these problems, we did so in terms of pi, which means we had a pi with every answer here. Anytime you're looking to get an answer that's not in terms of pi, you're just going to take 15 in this case and multiply by 3.14, or hit the pi button in your calculator, and you'll end up with the decimal approximation. In these last problems, we solved for either r or we solved for x, because we were given the arc length in each of those. So that's it. Keep in mind that arc length is distance. It is not degrees. The distance around a circle is unique to that circle and dependent upon the radius. But every circle has 360 degrees. So that's about it. Look forward to giving you some problems and see if you have picked anything up in this instruction. Thank you for your attention.